Welcome back. In this video, we're going to kind of practice some of the stuff that we've learned with object-oriented programming. I'm going to give you a public interface. Let me go ahead and show you that. I'm going to give you a public interface. This is for a class called Rectangle. From this, we see everything that is public in the class. Right? So what you don't see are private things like instance variables. That being said, looking at the public interface, you can kind of infer what the instance variables are. What I invite you to do is to maybe look at this, pause, and see if you can write this class on your own, right? Just from this public interface. This document will be made available on our CTLS and Canvas pages, LMS pages, and so you can also find it there. But I'm going to go ahead and step through this public interface and then program Rectangle. So right away what I see is this first thing here. My question to you would be, is this a constructor or a method? Okay, this is a constructor. My next question would be, how do you know? There's two ways that you can tell, right? For starters, the name of it matches the name of the class. That's one thing that a constructor has to meet, one qualification. Probably more importantly, because you can identify this in different contexts, right? If I was to cover up the rectangle part, like if you did not see rectangle, you could still determine that this is a constructor. How? Because we're missing a return type, right? The rest of these boys, they're methods. The way I know is this colon, right? This is a method. In order to read this signature, right, we have the getLength method. It does not take in any parameters. It returns a double. Here I have the setLength method. It takes in one double and returns, well, void, effectively nothing. And all of these things are in the rectangle class. So again, what I'm trying to communicate to you is that I can tell that this is a constructor because it is missing a return type. Okay, so we have one constructor. We're not overloaded, but this particular constructor takes in two doubles. Then we get down to our methods. We have an accessor for length. We have an accessor for width. Both return double. Based on what you know about accessors, you should be able to figure out instance variables kind of based on that. We have a getArea method. It's an accessor. It's not quite the same getter as these other two, and we'll see that when we go to write it. And then we have a couple of mutators. We have the setLength mutator. Takes in a double, doesn't return anything, and the setWidth mutator takes in a double, doesn't return anything. So based on this, you should be able to determine there's going to be two instance variables, length and width. Okay, we have a toString, and based on our previous video, you should be able to kind of figure out what that should look like. I'm not super particular on the formatting of that, but a toString should give us a string representation of the object. In practice, that means returning everything pertaining to its state. Let's get started. In Intellij, I want to make a new project by going to File, New Project. Our JDK is already selected. We'll go Next. We'll go Next. I'm already in my CSA folder, so I could just name this bad boy, and I'm going to name it Rectangle. Notice that as I type, the subfolder is being created for me. It's going to tell me, do I want to create the folder, blah, blah, blah. Yes, 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 yes. I'm going to expand my project folder, right-click on the SRC, make a new Java class called Rectangle. Okay. So looking back at our public interface, let's see if I can do a split screen on this. Maybe that'll help us. Ooh, Inception. Come on. Well, that's very finicky. I just want to drag my window. Thank you. So I got my public interface on the right-hand side. I'm going to ultimately kind of make that a little bit smaller maybe. And then we're going to make our coding window hopefully a little bit bigger. Ooh, looking like a boomer right now. All right. So based on my public interface, I can derive there are going to be two instance variables. Why? Well, I got an accessor for length and width, and I've got a setter for length and width. We'll get to area in just a moment. So I'm going to plug those in. You should also be able to figure out what the data types are, right? Here's an accessor for length, a getter for length. It returns a double. So I'm going to create private double length. I have an accessor for width. It returns double. So we can create private double width. Now, because both of these are doubles, we can actually condense this syntax, right? Right now what I have, that's perfectly fine. I'm just showing you other options. You could declare these both with the same declaration statement, right? We can do this in one line. Both length and width are private and double. So I can reduce a little bit of code by just declaring them at the same time. I'm then going to create my constructor. What some of you may try to do here is create an area instance variable. That is not what I would recommend. I'll talk about why a little bit later. Let's finish out the class. Right? I'm going to go ahead and write my constructor now that I have instance variables. We're going to create public rectangle. I'm going to take in two doubles, a double for my length, a double for my width. Using those two parameters, we're going to set the length instance variable to L, and we're going to set the width instance variable to W. That's it. I'm going to plug in my accessors and my mutators. Again, I like to group accessor with mutator, so I'm going to end up doing that here. Let's start with the accessor. I want to write this method right here. We're in the rectangle class. The name of the method is getLength. It returns a double, doesn't take any parameters. We're going to go public. Return type is double. Name of the method is getLength. And we don't take in any values, but I still need the parentheses. All this is going to do, it's a getter. We're going to return our length. Okay, I'm going to jump down and write the setter for length. We're going to go public, void, set length. Here we're going to take in a double, and I'm going to call that new length. What we're going to do is update the length instance variable. I want the length instance variable to become new length. And that's it. Here we have a accessor or a getter for length. Here we have a mutator or setter for length. Let's do this one next. A getter for width. We're going to go public, double, get width. We're going to return simply width. I'm now going to write a setter for width. I'm going to go public, void, set width. We're going to take in some double. It kind of doesn't matter what we call it, but I like this idea of calling it something like new width. Our width will become new width. Okay, we're actually speeding right through this. Area is going to ultimately be the last thing that I do. I want to get to a point that I can test this, right? I can test the constructor. I can test these getters and setters. I want to be able to test both of those things, and I need to be able to see that stuff. So I'm going to write my toString next. We are going to go public string toString. Recall from our last video, the purpose of the string is to return a string representation of the object, of this object, something like that, right? In this case, it's a rectangle object. One of these days, I will A, learn how to spell, and or B, learn how to use the spell check in here. Okay, so what we're talking about, in practice what this is the state, aka the state of the object. State, as you recall, is made up of all of the instance variables. I only have two. Okay, I've got length and I've got width. So I'm going to, at the point of return, concatenate a string. We are going to annotate this string by including a string literal, displaying our length. I then want to tack on the length instance variable. As you also saw in our last video, having new lines is really nice. In the past, we've used SOPs in order to achieve that, system.out.print lines. That's not advised here, right? We want to stick with strings. What we did learn was the new line character. This is actually a single character. Here I am encapsulating it with double quotes, indicating this is a string. This is technically a string with a length of 1. But to demonstrate that it is a character, I'm going to put it in single quotes, right? Meaning it is a char literal. Intellij wants me to finish out the string, but notice this is not a syntax error, right? So I am creating a string here. We have a string literal, and then we're going to tack on our double value. This will be a string. I'll take that string, I'll then tack on a single character. It is the new line character. That's going to cause a new line to be generated in our string. In order to kind of show this in code, I like to then go down to the next line, where we're going to tack on our width. And again, this is a single character. Why don't we kind of pause there with that, right? So I'm gonna have I have a toString. It's supposed to give me a string representation of the object. That's ultimately the state of the object. The state is comprised of all of your instance variables. In this case, only length and width. I'll talk about area in just a moment. So this will be one method that I could call to effectively get both as a result. Sweet. Let's test the stuff that we got so far. I'm going to right click on the SRC, make a new Java class. I'm calling that driver. I'm going to plug in a main method with PSVM. Okay, let's create a rectangle. I only have one constructor. There's only one possible way. In order to create a rectangle, we're going to need a length and a width, right? I don't know, why don't we do something like 2, 3? I recommend making these things different values. I also recommend not using something like 1 or 0. More on that later. Okay, so I've created a rectangle. It has a length of 2, a width of 3. What I then want to do is, well, let's see what the initial state is by printing off the rectangle. Recall that whenever I try to print an object variable, what I'm actually doing is implicitly calling the toString method. That toString method is going to produce this string, return it, and then my SOP is printing it off. Let's right click in free space and tell it to run. What we're going to see is that our constructor is working, right? Because it is correctly setting a length and a width. And even though I use integers here, they're doubles. So when they get saved in, they're going to be treated as doubles for the life of the object. Okay? I then want to maybe test my other methods, right? Let's test out our setter. I'm going to set length to 14. Why don't we do an actual double, like 14.3? In order to see that, I could call the toString, but I also want to test my getter. So let's call rect.getLength. And I'm going to run this to see what my results are. Maybe I'll pair those together. Here you see it's just a simple number, because that's all the getLength is doing, is returning that double. Last, let's try our setWidth method. And let's again use a crazy double. I will see that by calling the getWidth method. So I set my width to 5.7. I'm going to get my width in order to test both of those methods to see that they are working. And everything looks good, right? We've tested our constructor. We've tested our toString. We've tested setLength and getLength. We've tested setWidth and getWidth. The last thing that's on our public interface is area. Okay? Now, I'm going to show you what some students do, and we'll talk about why it's not a good idea. Some students see this and they go, oh, that's an accessor, that's a getter. I need an instance variable for that. Notice there's no setter. Okay, so they come in and they include in this area, right? We're going to tack on this third instance variable, right? And maybe when we create our rectangle, we go ahead and set area. Hopefully, you know what the area is or how to calculate area. Simply put, it's length times width. So we can do that here. Technically, in this scope of this constructor, we could have used L or W and or W. At this point, right, length has been initialized, right? This is the very first thing that happens. We save L into length. So length does have a value at this point. Same thing with width. We're saving W into width. So width has a value at this point. I am multiplying length times width, and that gives me my area, so I'm saving that into there, okay? Again, I'm demonstrating an idea that you don't want to go with. Okay, so simply put, whenever we go to get our area, which I'm going to plop down here, right, we go public double get area, and we just simply return that area instance variable. This kind of makes sense, right? So I'm going to run you through the process again, the thought process. Area, maybe I need a double to store that area, so I include another instance variable. I initialize it in the constructor as soon as I get my length and width. We create a getter that all it does is return that area. Okay? So now, what we end up doing is, and we end up calling it. So I'm going to maybe print off rect.getArea. Okay, and at this point, rect has an area of 6.0. Well, that's not right, right? Because it should be 14.3 times 5.7. Hopefully you're starting to see the issue. Right? Based on my code, I initialized area at the point of construction. Right? So right here, area is being set to 6.0. Why don't we include it in our toString? Even though it's not particularly an instance variable, it's kinda. Area is going to be area. Right, so right away I create my rectangle with a length of 2 and 3. We then display it, right? We print it off. So we see our length, our width, and in that constructor, we are performing a calculation. We're initializing area, 6.0. That looks good. However, the problem is I come in here and I change my length, I change my width, but I didn't change my area. So the next thought process is, okay, well, whenever I set length, let's also update area. And what you end up doing is creating a lot of overhead here. This would create something known as variable shadowing. What do I mean? You have a variable area whose value depends on other variables, and it's shadowing them, and that every time we update our length, I then need to recalculate area. We want our program to be more dynamic than that. So I'm going to back all this up, right? I'm going to get rid of the area instance variable, which means there's nothing to set in our constructor, right? I don't want to update it if I were to update length. Instead, my approach is going to be whenever I want the area, I calculate it then in the moment. Simply put, we're going to return length times width. Right? This is more dynamic. Why? Because whenever I ask for area, I calculate it then. If length and width update, it doesn't matter because I'm using the latest value for length and width. Okay? This does mean that our toString is a little bit wonky because it's referring to an instance variable, but a big brain thing we can do is instead of referring to that instance variable, we call the getArea method. Okay, I'm going to run my program, and then we're going to kind of follow the flow to see what's going on here. So in my driver, we are creating a new rectangle. This is like one of the first things that happens. We jump to the constructor. It's passing in 2 and 3. So 2 goes into length, 3 goes into width. Boom. Those variables now have values. We then save that into rect, this variable. We then call rect.toString. Let's jump to the toString. What does it do? It starts creating this string, right? We are concatenating length with the length instance variable. We'll make a new line. We're concatenating this string literal with this variable. We make a new line. We're concatenating this string literal with everything, and then we call the getArea method. Let's go to the getArea. GetArea calculates length times width. That's 2 and 3 at that moment. So we get a value of 6 that gets returned, and then that gets tacked onto the string, and this is the string that ultimately gets produced by our toString. I then set my length to 14.3. We can see that here. I then set my width to 5.7. We can see that here. And whenever I get down to here, I'm going to call rect.getArea. Let's go to the area method. It's going to call getArea, and we're going to do length times width. At that moment, length is 14.3, right? We had updated it. At that moment, width is 5.7. We just updated it. So I get the latest and greatest calculation in the moment, and this makes it more dynamic. No need to constantly update some crazy instance variable. We just do the calculation when we need to. Okay. In theory, there's trade-offs there, right? In theory, if this was like a huge calculation that took like a lot of time, having to do it over and over and over again is not great. In this case, it's just simple multiplication, right? So this is better. We get a more dynamic program. And yeah, that's rectangle.